Hi, today we're going to talk about Archimedes' principle and do a little experiment that demonstrates that. Archimedes was an ancient Greek mathematician and scientist, and he discovered how boats float. Archimedes' principle states that the buoyant force on a submerged object is equal to the weight of the fluid that is displaced or moved out of the way by that object. So we will see if the weight of the object is heavier than the weight of the water it displaces or moved, that object will sink. If the weight of the object is equal to the weight of the water that it displaces or moves, it will float. So let's try it and see if it works. So we have this contraption set up here, and this is full of water right at the level of this. And so any water that's moved will come up and be able to be let out. And we'll weigh that water and see if it equals the weight of our object. So our first object we're going to try is this ferry boat. Let's see how, so the first thing we're going to do is zero our scale and see how much our little ferry boat full of cars weighs. It weighs 1 pound and about 2 ounces. So let's write it on our chart. Let's see if our boat floats. Well, it sure does. Okay, so now the level of water has risen or moved out of the way. So we're going to check the weight of that water and see if it's equal to the weight of the boat. So the first thing we're going to do is zero our scale again with our water container. And then we're going to put our water container right under here and open this valve. It's a little slow process, so we'll check back in a minute. Okay, we can see our water has stopped flowing, so let's close our valve and see what the weight of our water is. Oh, look at that, it's 1.2 ounces. 1 pound and 2 ounces. Wow, that's pretty interesting. Let's maybe try something else and see what that does. Let's pour our water back in. Zero our scale. And let's try this rock and see what that does. Let's see. First we'll weigh our rock. Ooh, that is 1 pound, about 7 ounces. So let's write it on our thing. Let's check that our ferry boat did float. 1 pound, 7 ounces. Let's see if our rock floats. Oops, that certainly didn't float, did it? Well, let's see how much water is displaced by our rock. So we're going to zero out our scale again. And see how much water comes out. Okay, all the water that has come out, that will come out, that's been displaced, and let's look at the weight of this water. Oh, it's only 7 ounces. Wow, that's a lot less. Let's try something else just to make sure that we're on the right track. How about this cute little octopus? tricky time getting my scale here. There we go. Okay, he weighs 5 ounces. So let's see how he does. Well, he certainly does float. Let's see how much water he displaces. He floats and he weighs 5 ounces. Okay, we've gotten all the water out of there. Let's see what that water weighs. Oh, look, it weighs 5 ounces. Wow, okay, let's try a little bit, let's try something different and see if we can. How about this dish? It looks like the shape of a boat, so it might float, right? Okay, that weighs 1 pound, 1 ounce. So let's see. 1 pound, 1 ounce. Let's see if it floats. Uh-oh, that didn't float. Well, let's see how much water we get out of here. Okay, all the water has run out. Let's see what it weighs. Okay, it weighs about 5.5 ounces. That's how much water we got out. 5, 1. Okay, let's try one more thing, just to see, but it looks like that our data is correct. So, let's try this ball. Okay, well that ball is also about 5.5 ounces. Does it float? Well, it certainly does. Let's see how much water it displaces. Our ball does float, and it was all that water in. Okay, all the water is done flowing out. Let's see what we got here. Oh, we got about 5.5 ounces. Look at this. We can see that if the weight of our object was more than the weight of the water that it displaced or moved, our object sunk. But if the weight of the object was equal to the weight of the water it displaced, our object floated. It looks like we've demonstrated Archimedes' principle.